Next, we are going to be answering this question here. We are given figure 2 here, and in this figure we have three processes A, B, B, C, and C, A here. So basically the first question is calculate the temperature T2 at the end of the isobaric process in terms of T1. So for A here, we have to identify the isobaric process, and we know that isobaric means there's no change in pressure, meaning our isobaric process is A to B. A to B is our isobaric process because there's no change in pressure. As you can see, this process here is completely horizontal. It doesn't move along the y-axis here. So that's our isobaric process. You can also say here your reason why this is isobaric. And then from there, for an isobaric process, we know that the pressure is constant, right? The pressure is constant for an isobaric process. So if the pressure is constant, we can then conclude that VA over TA is equals to VB over TB, like this, right? So in here on our process, let me try to redraw this again. Oh, maybe I'll just annotate right there. Another thing to remember is you can draw the isotherm here, right? You can say this is our T1, right? And then you can draw the other isotherm here, which is going to be our T2. So at this point here at A, you have V1 and you have T1, right? And at B here, we're going to have our V2 and our T2, right? So to substitute here, VA is going to be V1, right? And then TA is going to be T1 is equals to VB is going to be V1 over 2. As you can see here, got our V2 is equals to this value over here, right? And then I'm going to divide that by T. Let's say T2. That's our T2. So to calculate the value of T2, because that's what the question is asking for, we are going to multiply by T here, right, to make it the subject of the formula. So I'm going to multiply both sides by T2. Say multiply both sides by T2, and then here we're going to have T2 V1 over T1 is equals to V1 over 2. And then I'm going to multiply both sides by T1 to get rid of that T1 at the bottom. So I'm going to have T2 is equals to V1 T1 divided by 2. I forgot about this V1 here. So we have V1 T2 is equals to V1 T1 divided by 2, right? So we're going to divide both sides by V1 to make T1 the subject of the formula. So we're going to have T2 is equals to V1 T1 divided by 2 multiplied by V1, right? And the V1 here is going to cancel this V1 here. We're going to be left with T1 over T2. So our T2 here is going to be equals to this. This is T2 is equals to T1 over 2. So that's our T2, right? That's our T2. And next, let me choose another color here. The question B is asking for the pressure 2 for the isochoric process. The isochoric process is going to be the process in which volume doesn't change. So the vertical process here, which is B to C. And we're going to do the same thing we did here. So we're going to say for an isochoric process, the volume doesn't change, right? It remains constant. So change in V is equals to 0, right? So we can then conclude that P, we're talking about PB here, divided by TB is equals to PC divided by TC, right? And then here, we are going to look at our T's here. As you can see here, T and C, they lie on the same isotherm here, which is T1. So Tc is equals to Ta, right? And is equals to T1. That is true because they lie on the same isotherm here. So we can say Tc is equals to Ta is equals to T1. So our Tc here is equals to T1. And we're going to substitute our Pb, which is here, is going to be P1 here. So we're going to have P1 divided by Tb is over here, and it's this T2 here, right? So we're going to have T2, and then here is equals to Pc. Pc is going to be P2, right? We have P2 here. We're going to divide that by T1, as we've previously noted that Tc is equals to T1. So to calculate everything here, we just have to make this one the subject of the formula. To do that, I'll just multiply both sides by T1 to get P2 is equals to P1 divided by T2 multiplied by T1, right? So to get our final answer, we just need to substitute T2 with the value we got from this question over here. So I'm going to say P2 is equals to P1 divided by, that was T1 is equals to, T2 is equals to T1 over 2, right? Multiply by, I can just say T1 here, right? So to solve this mathematically, I just do some maths. So I'm going to say here P1 T1 divided by T1 over 2, like this, right? And then I'm going to say P1 T1 multiply by, and flip these two. I say 2 here, and then I say T1. So I'm going to have 2 P1 T1 divided by T1, and these two are going to cancel. So we're going to have P2 is equals to 2 P1. That's our final answer for P2. So we have our A and we have our B, right? So for our C, we are going to have to do some reasoning. I've seen people do calculations for this, but I'm lazy to do all the calculations. It says, is the work done by or on the system? Justify your answer from the diagram. So for this one here, what I like to do is look at the processes. Okay, let me try to erase this so everything is clear. Okay. To answer this one, what I like to do is look at the processes. First, you can see that this process here does no work. If we're saying that work is equals to P dV, you know that there's no change in dV for this process here, so this is going to be 0. Therefore, total work done by BC is going to be 0. You have to write that. Total work done by this one is going to be 0, right? So we're not going to consider that. And then for AB here, you know that the total work done is going to be the area under the graph here, right? And by the way, this process here is compression because our volume is decreasing, right? Our volume is decreasing. It goes this way. Remember that our volume increases this way and our process goes in the opposite direction. Our volume is decreasing, meaning our process is compression. Compression does negative work, right? And then this process here is the only one that's left. This one is isothermal expansion, which is positive, and it has a larger area under the graph, right? So let me see. Okay, I'm gonna say the first process here, it does negative work and it does this amount of negative work, right? This is the area under the graph. But this process here, if I extrapolate it and draw it here, right, I'm gonna say the work it does is this one here, right? And it does positive work. So if we add the two, we're gonna get a positive value, meaning the work done by this entire system here is positive. The net work done is going to be positive. If the work done by a system is positive, it means the system does work. It does work. If the work done by a system is negative, it means work is done on the system. instead of the system doing work, we are putting work into the system. So to answer this question here, net work is done by the system because our W net is going to be positive, right? The larger value here is positive work, right? So let me try to erase everything. Everything's getting dates here and dates here. I hope you guys took notes on that, so I'm gonna erase this. I hope I'm not gonna need it, but if I need it, I'm sure I'm gonna need our conclusions only. I won't need the rest of all this stuff, so I'm gonna erase it. Let's go erase all this. Okay. Erase all this. Naked beach cedar. Be humble. Okay. And then I'm gonna select my pen again. For D here, D is gonna be a difficult one. Calculate the network done by the cyclic process. This one requires some differentiation, but I'm gonna avoid that. I'm gonna say B to C does 0 work. So let me try to demonstrate this. W B to C is equals to 0 because that's isochoric, right? There's no volume change, meaning it does 0 work. So we only need to find the work that is done by this process and also this process. So first, WAB is going to be equals to P dV, right? So this is going to be P into V2 minus V1, right? So our P is going to be P1 because A lies on P1. It's going to be P1 here. So we're going to say P1. And our V2 is going to be this here, right? It's going to be this one. So we're going to have V1 divided by 2. And then I'm going to say minus here, V1, right? Because our V1 is this one here, right? And then all we need to do from here is do some maths to get our final value. So I'm just going to multiply out. I'm going to multiply out to get P1, V1 divided by 2 minus P1, V1. When we multiply this by this, we get this. And we multiply this by this again, we get this, right? So I'm going to say it's equals to, and to solve this, I can either take a common factor here and then do the maths, or I can factorize. Let's say I take P1, V1 because that's common between these two. Put that in brackets. Here we're going to be left with 1 over 2. And then here we're going to be left with 1, right? And then here, if we subtract this one, we're going to be left with minus 1 over 2. So P1, V1 into minus 1 over 2. We multiply back out, we're going to get P1, V1 divided by 2. So that's our WAB, right? That's the work that is being done by this process over here. So I'm going to do this, erase everything again, and then select another color. So now we need to find the work that is being done by this process over here. And also, please make sure that you note that work here is negative, it aligns with our, you can know whether a value is correct or not by looking at here. You can see if we get something that's positive, then we did something wrong, because this is compression here. It's supposed to be negative. So let's try to find WCA. Okay, one unique thing about WCA is we can't just say W is equals to P dV, because here our pressure is not constant, right? Let's see, for this process here, we can just plug our P1 here, right? We can just plug our P1 here, because you can see that this process, it lies only on P1 here. But this one here, it goes from here to here, meaning there are multiple P's here, right? It goes from P to P1. We can't just plug in P1 here and be done with it, right? So there's a formula for isothermal processes. Okay, when I drew my isotherms here, you can see this process lies on T1, meaning it's isothermal, right? For any isothermal process, you can calculate the work that is being done by that process with this formula. WC to A is equals to nRT into VB over VA. Or in this case, I'm going to say this is VA over VC, right? And then I'm going to substitute. Our N here is 1 because this is saying 1 mole of a gas here. We're going to have 1 RT into, okay. And then our VA, let's say VA here is going to be V1, right? Because you know this is V1. So we're going to have V1 here. And then we're going to divide that by what? We are going to divide that by, let's see, our VC is this one here. VC is going to be this one here. We're going to have divided by V1 over 2, like that. And then let's try to recalculate this one. It's going to be RT. And then we're going to have, let me see. V1 divided by V1 over 2. I'm going to multiply this out. Let's say V1 multiply by 2 over V1. I'm going to be left with 2. So this one will cancel to 2. All this will cancel to 2. We're going to have 2R here. That's what we're going to be left with, I think. Because let me see, our VA is our final. So this one VC, yeah. WC to A here is going to be this. And so this process here does 0 work. I'm a bit messy. So this process here does 0 work. This process here does 2 RT work. This process here does minus P1 V1 over 2 work. So W net here, to calculate the work done, W net is going to be the addition of all of those. So I'm going to say W net, my pen is not big enough, is equals to WA to B plus WB to C plus WC to A, right? And then we're gonna have this one, let's say it's minus RT, right? It's 2RT. This one does 0 work, and then this one does minus P1 V1 divided by 2, and then we're gonna have 2RT minus P1 V1 divided by 2. So this is our network done. This is going to be our network done. Let's see, we can substitute this and this, but we don't have values for this, so I'm gonna leave it like this. Let's hope this one's correct. If you think I did something wrong, or you have another explanation, or you have a memo from a previous experience, please let me know. Thanks for watching. See you in the next video.